Well, I've been degreeing my cam in over the last little while, and this is the cam. I have 3 of these. They're all the same. They're a Megacycle 250-30. Not that that matters, but that's what it is. That's what they are. And I also had the sprocket modified to be adjustable. Right? You can see these 3 screws there. You can undo those and rotate the sprocket. Actually, here's one that doesn't have the screws in. See that? That's so you can degree the cam in to get it just right if it's not that way from the factory, and like the sprocket may have been pressed on in just a little bit out, and rather than with the stock sprocket, it's a press on fit, so you have to press that out and press adjust it to whatever way you want, basically taking a guess at it, press it back on, put it back in the engine, use your degree wheel and your dial indicator, and that's very time consuming. So that's why these exist. Anyway, I was about to fit this. Well, anyway, I got it timed, right? I got the cam degreed in, and I was about to put the cam in the engine for the last time. So once I got it degreed, I took it out and took the screws out, cleaned them all and everything, because you want to run them with Loctite. And these are also drilled for safety wire. I'm not sure if you can see that, but they're drilled for safety wire. The idea being that as these rotate, if one of them ever backed out, the damage would be horrendous. So I took it out for the last time, cleaned it all, and I was about to put it back together when I thought to myself, when it was in the engine and I was turning it over by hand, using the degree wheel as a crank, right? You can't use the nut on the left side of the crankshaft because it has a right-hand thread on it. So as you turn the motor over in the direction of rotation, you're actually undoing the nut. So if they put a left-hand thread on that, like some bikes have, that'd be great. But they didn't. So I'm using the degree wheel as a crank handle like this, and my engine is rephased. It has a 90 degree crank in it, or a 270, call it what you like, they're the same thing. And whereas the stock engine has a 360 degree crank, and so the cylinders fire alternately at even intervals, you would find that on a stock cam you would have two lobes here, and the other 2 lobes would be here, right? In other words, opposite. So the engine is quite easy to turn over with the spark plugs out. The only resistance to turning over is the valve springs, and because the valve events happen evenly, there's an even effort required to turn the engine over. But when you rephase the crank, you also rephase the cam. So looking at this, you can see that the lobes are not opposite each other from one side to the other. So what that does is, as you're turning the engine over, there are parts of its rotation where you're only compressing, say one valve spring and maybe partially another valve spring partially. Pardon me, it is very hot in here. Oh. And there are other times in its rotation where you're probably compressing 3 valve springs all at one time. So in other words, as you're turning the motor over, it's sometimes quite easy, and then you'll get to a very, very difficult part and you've got to go like that to get it past that part of its rotation. So the cam action in a rephased engine, rather than being constant and smooth, is quite jerky, right? So what does that have to do with anything? Well, the way that the sprocket is held onto the cam, it's just a slip fit like that. Wait a minute. We'll get that on. Once it's on there, you'll see that it is just a slip fit there. Right? Right? Now it's not keyed at all. right, you can see that the slots, right, which allow for changes in timing, right, and you'll put a screw or 3 screws in like this. Okay, so that's in there, and now you can, now it'll move, you know, to the limits of those slots. But what's holding it on there, what's holding the sprocket to the cam is simply clamping force from those 3 screws. Now, of course, you would, once you had the timing set to where you want it, you would do those 3 screws up as tight as you could with an Allen key, and you'd Loctite them, and you would even safety wire them, right? So they're not going to back out. But what if the clamping force is not enough to overcome the resistance of this engine? And I should tell you that this is quite a big cam for a street bike. As I said, it's a Megacycle 250-30, which is not a race cam, but it is at the upper end of what you would put in a street bike. So that means that it has way more way more lift than the stock cam. So you're trying to compress the valve springs more than you were before. I dare say the opening ramps are a little bit steeper, so you're trying to compress the valve springs instead of smoothly like that. You're trying to compress them like that, and as I said, there are times when you are trying to compress probably 3 valve springs at once. All right, so all of those things combined could create a situation where the crank is turning the sprocket, right? The crank is turning the sprocket, but the valve springs are trying to stop the cam from rotating, and maybe the cam would move like that. Right? I'm not saying it would. The fellow who made this sprocket says that he sold lots and lots of them. Megacycle make them. I think Mike's XS have them. Hyde & Tuning probably has them, and I don't know if the sprocket slipping on the cam has ever been a problem for anyone. But it's one of those risks where the chances of it happening are very, very slim, right? But the consequences, if it did, would be catastrophic. So I'm simply not prepared to take that risk. So what I've done is I've got the cam to where I want it, right? I took it out of the motor and I drilled 2 more holes. I'll just line those up so you can see them. There we go. So I drilled 2 more holes, one there and one there, and they go through the sprocket and into the cam in line, right? So what we do now is we put the screws in here, and they're being a pain, so we will get our Allen key and try again. Of course, to put these in, you have to get the alignment just right. And that's the whole point of it, is that once these are in, the cam cannot move on the sprocket. There. Now, cam can't move. I can even take the one out that's in the slot. Not that you would, but this is just for demonstration purposes. And the sprocket still can't move on the cam. All right. Now, while I was about that, I thought to myself, wouldn't it be nice if you could change the cam timing without going through the whole process of putting on the degree wheel and the dial indicator and all that other stuff again? Now, as I said, this is a pretty hot cam for a street engine, and we know that changing the cam timing it doesn't make any more power, but it does change where the power comes in the rev range, right? So if you advance the cam, that lowers the rev range where the power comes on. If you retard the cam, that lifts the power up in the rev range. I can't imagine that I'd ever want the power to come on higher than it's going to, but I may want it to come on lower. So rather than just drill the 2 holes, I drilled 3 sets of 2 holes, each in different locations. So I have one set at straight up, which is as per the manufacturer's settings. I have another set drilled at 2 degrees advanced, and I have a third set drilled at 4 degrees advanced. So if I find that the engine is a little bit too peaky, I can simply loosen the 3 screws off that are in the slots, then take these 2 out, rotate the sprocket, right, around to a new set of holes, do them all up again, do all the screws back up again, and I've changed the timing to a known amount. So that's pretty good, I think. That might come in handy. I may never want to change the cam timing, but if I do, it'll be a 5-minute job. Now, one other thing that happens when you rephase a cam, as I said, you put the lobes, or you change the location of the lobes from 2 pairs opposite each other to 2 pairs not opposite each other. And what that does is it makes for a heavy side and a light side of the cam. And we watch this go around. Right? And you'll see that there it goes. See that? It wants to settle with the heavy side down, just like balancing a wheel. There it goes. Now, whether that would upset things, I don't know. I don't know if there's enough weight in that to create any kind of noticeable vibration. But the whole point of having the engine rephased, especially to 90 degrees rather than the more common 83, is to make it as smooth as possible. So I haven't gone to all that trouble of doing that and having the engine professionally balanced. And when I had that done, I had to give the guy that was balancing the engine, and that is his full-time occupation. This is a fellow who does nothing but balance engines all day, every day. That's all he does. So I gave him all my parts, the flywheels, or the crankshaft, all the crank pins, the rods, the bearings, pistons, pins, rings, everything, and they all had to be in the condition that they would be going into the engine. Right? That means piston skirts shaved if that's what you wanted to do. Crowns modified if you had to, and by the way, I did. Rings gapped, so that everything weighs what it's going to weigh going into the motor. So I gave him all the parts in that condition, and believe it or not, he said very little work had to be done, which is great, saves me money. The more time he spends on it, the more it costs. But as it was very close to being perfectly balanced anyway. But anyway, that done, right, we now have this. So I thought, since I've got it apart and sitting in V-blocks, might as well balance it. So what I did was, I'll have to take this apart, I think, for you to see it. So what I did was, I drilled these 3 holes on the heavy side, and each time I drilled one, I put it all back together, put it in the V-blocks, spin it, find that I needed a second one, did that again, found that I needed a third one, so I did that again, and that is very, very near perfect. So I'll put that together and run it for you. Right? But just look at this one more time. Don't know if you can see it from where you are, but it is quite rough in its rotation. There you go, settled on the heavy side again. Give me a minute and I'll be right back. Alright, so I've put all this back together. Let's spin it. And you can see it stops there, doesn't want to roll back. There. Stops at a different place every time. There you go. So the cam is now balanced. As I said, I don't know if it would make a noticeable difference, but I just thought I would do that anyway. You might be able to see this, right? Yeah. Can you see that hole there is not quite lined up with the hole behind it, right? The reason, of course, is that it's off by 1 degree. Right? So there you go. When I was doing this, the way I located the holes was to start off with one hole, and we'll call that 0 degrees, and that's the hole that I drilled with the sprocket in place, right, and at the location that I wanted it. So I started off there, and there are 3 holes, so 360 divided by 3 is 120. But I didn't go around 120 degrees. I went 121. Right? 1 degree on the cam is 2 degrees on the crank. So that's where we get our 2 degrees advanced. And then from there, I went around to 242 degrees. So another degree on the cam, another 2 degrees on the crank. And then I came back, drilled the second hole, right, the second one of the first pair, did the same again, 121, 242. So that is my cam, and I'm quite happy with it. That's about all you can do to a camshaft, I think, is have it ground to the grind that you want, have the adjustable sprocket put on, and make that slight modification to enable a future change of timing to be easier than it would have been, and if the engine is rephased, balance the cam. There you go. We'll see you later.